Okay, this video is to help you get started on the scale factor slide lesson if you're absent. Okay, we've been dealing with solving similar figures, and whenever we've been finding a missing side of two similar shapes, we've been using a proportion. Okay, and those rules still apply. Okay, but there's something else going on that we haven't really talked about yet, and that is when you have two similar shapes. Okay, let's say you're going from a smaller similar shape to a larger one. Okay, you are actually multiplying each of the individual side lengths by the same number to get to the new side length. Okay, now usually it doesn't work out to be a nice easy number like 3. Okay, so maybe it was 1.5628. Okay, but you're still multiplying every side of one shape to get to another shape. It's always the same number you're multiplying by. Okay, so if you look at these two similar shapes here, okay, 5, okay, turns into 15, and 2 maps to 6. Okay, so everything's getting 3 times bigger. Okay, so if every side is getting 3 times bigger, we say that the scale factor is 3. Okay. It does matter how you talk about scale factor, the order. Like if I was looking at these two shapes and I was saying that the scale factor from parallelogram ABCD to WXYZ, I could say its scale factor is 4, okay, because you continually multiply every side by 4. Okay, but if I was thinking backwards and I wanted to say the scale factor from parallelogram WXYZ to parallelogram ABCD, I'd have to say that the scale factor is 1/4. Okay, because you multiply by 1/4 to get from one side to the corresponding side. Okay, so you've done this. We just haven't talked about this vocabulary. Okay, take a minute, do the next slide. See if you can figure out the scale factor. I'm giving you sets of similar shapes. See if you can figure out what the scale factors are. Okay, the first one's trapezoids. Okay, 2 goes to 10, 3 goes to 15, 5 goes to 25. The scale factor is 5. Okay, everything's multiplied by 5. Okay, we have a few pentagons here that are similar. 2 turns into 12, 4 to 24, 3 turns into 18. Okay, notice you're always multiplying by 6. So the scale factor is 6. Okay, here's 2 quadrilaterals. 5 turns into 15. 7 turns into 21. 2 to 6. Okay, everything's multiplied by 3. Okay, so the scale factor is 3. Okay, have some problems. I'll do 2 of these with you. I'm going to see if you can do some of them on your own. But what we need you to be able to do for iLearn. Okay, what we need you to be able to do. You may be given a shape, an original shape, like a rectangle that's 3 by 5. Okay, and then they may ask you questions about the enlargement, could be reduction, okay, but about the new shape after they give you a scale factor. So for example, in this problem, you have a rectangle that's 3 by 5. We want to be able to know how to find the new length and width, the new perimeter, okay, the new shape, and the area of the new shape just by the fact that the scale factor is 4. Okay, so let's just do this. If the original rectangle is a 3 by 5 rectangle and the scale factor is 4, okay, let's first find the new length and width. Okay, that's simply multiplying the length and the width by 4. Okay, let's see. 3 times 4 is 12. 5 times 4 is 20. Okay, and from there, we need to be able to find the perimeter and area. Okay, perimeter is just adding all 4 sides up. There's 2 20s, there's two 12s. Let's see, 40, 50, 64. 64 centimeters would be the perimeter. Okay, the area of a rectangle is length times width. So that would be 20 times 12, which is 240 centimeters squared. Okay, try the next one on your own. Okay, pause the video. Try the triangle one on your own just to make sure you can do this. Okay, then we'll check it over. Okay, so we have a 3 by 4 by 5 triangle. Okay, we're going to enlarge it with a scale factor of 3. Okay, we want to be able to find all 3 sides, and then the perimeter and the area of the enlargement. Okay, so let's see, if the scale factor is 3, I'm going to take 3 times 3, that's 9. I'm going to take 4 times 3, that's 12. I'm going to take 5 times 3, that's 15. Okay, so this is the side lengths of my new triangle. Okay, now I didn't officially tell you this, but this was supposed to be a right angle right here. Okay, so this is a right angle right here too. Okay, it looks like it, but I should have put in a little square to indicate that that is true. Okay, now to find the perimeter and area. The perimeter, we just add up the 9 and the 12 and the 15. Okay, that's 36 centimeters. Okay, the area of a triangle is 1/2 times base times height. Okay, so it's going to be 1/2. Now remember, in a triangle, the base and the height, that the height has to form a right angle with the base. Okay, so the base is 9 and the height's 12. Okay, we don't even need to use the 15. Okay, we're just using 9 as the base, 12 is the height. So it's 1/2 times 9 times 12. I'm going to try to do this without a calculator, and I think it's going to be easier to rearrange the 3 numbers that I'm multiplying together, because I know that 1/2 times 12 is the same as 1/2 of 12. Okay, and 1/2 of 12 is 6. So I can just take 6 times 9, which is 54. Okay, let me know if you have questions. I'm going to mention a couple more things. I do want you to be careful. The first thing I want to say is, when you have an original shape, just be careful not to take, if they ask you just for the area of an enlargement, don't just find the area of the original shape. Like I could find the area of this original shape would be 6. Don't just find the area of the original shape and then multiply that by the scale factor. Okay, it won't work. The scale factor, you want to apply that to lengths of the shape, but not to the area. Okay, we may get into this a little more detail later. Okay, but just apply the scale factor to the original side lengths, and then from there, find the area. Okay, second thing I want to mention is, if you look at this, let's see, slide 7. If they say something like, in a drawing, 1 inch is equal to 9 feet, okay, it's kind of related to scale factor, but it's just called a scale, because you have the units, but it's still the same idea. Okay, do the best you can with these, and let me know if you have any questions at all.